Hi guys. After looking through your Know for Your feedback, I definitely have some worries. I don't know if it's because it was homecoming week or because I was gone on Monday or because you just didn't try very hard in Know for Your feedback, but your notation is awful. Um, it's like you never learned it at all. So I'm going to go through some of this with you, but be prepared on your quiz. If your notation's wrong, you're going to lose a lot of points because this is the bread and butter of calculus. It's kind of like not being able to show proper notation in solving an equation in Algebra 1. If you can't show this correctly, don't expect to get much of any points, even if you get the right derivative at the end. So first things first, in question 1, it's asked you to find the derivative of f of x equals the square root of x plus 2 by the limit process. So let's talk about the limit process. So we're going to start with f prime of x equals, that's something you should have done a million times up until this point. And then you're going to say equals the limit as h approaches 0 of the square root of x plus h plus 2, because you're evaluating for f of x plus h, minus f of x all over. And if you remember the original definition was x plus h minus x. And that's why when you go to simplify, you're really left with the limit as h approaches 0 of the square root of x plus h plus 2 minus the square root of x plus 2 all over. These two x's, you're subtracting an x from an x. That's why it's over h. That's where that comes from. I'm going to erase this for the sake of space. On this step, and you should have gotten this when you did rationals last year, but you guys are awful with your parentheses. Without them, you are only multiplying part of it, and it's unclear what part you're multiplying by. So now you're going to multiply by a conjugate. So the square root of x plus h plus 2 plus the square root of x plus 2 all over the same thing. Do you notice how everything has a clear line and parentheses? Everything is legible. I can tell what's in the numerator and denominator. You really shouldn't write fractions with a slash mark. That should have gone away back in middle school. So if you didn't take that notation away last year, now's your chance. Okay, so now we're going to actually multiply out. We're going to say the limit as h approaches 0. This is when we multiply this by this. So you get the no square root, x plus h plus 2. And then you're going to multiply outside, which would get you the square root of x plus 2 times the square root of x plus h plus 2. And then when you do inside, you'd get negative square root of x plus 2 times x plus h plus 2. So those two terms will be identical but opposite, so they cancel. So then you're going to say, well, this times this is a negative x plus 2. Again, the notation on these two lines was just atrocious. I know you've been behind on time lately. I'm hoping that's why you're cutting these types of corners, but there was no reason to do that on the Know for Your feedback yesterday. So you're going to have h times the square root of x plus h plus 2 plus the square root of x plus 2. So that's what this should look like. Clear, legible, proper notation. If you haven't been doing that in your homework, you might want to take a few steps back and do the questions, the odds that are optional in the textbook, and make sure you're practicing correctly, because I think some of you have formed some bad habits. So now in this next line, we're going to say, well, we have x minus x and 2 minus 2. So this is one line of work right here. I know it's tempting to cut corners and to do too much canceling in one step. You cannot form that habit now. You're going to make errors that are like impossible to correct later if you do. So that is one line. Then another line would be saying, well, the h over h, that part becomes 1 because anything over itself is 1. And if you notice, I still have the limit as h approaches 0 on every single line. I've not found my limit. If you lose that limit, there goes all your points in this problem. They're all gone. So now we're here, and now we can evaluate for the limit. So we get 1 over x plus 2 plus x plus 2, which simplifies down to 1 over 2x plus 2, or 2 radical x plus 2. This is how your work should look. This isn't the time to be creative or think about other ways to show your work. This is literally the standard I'm teaching is, can you find a derivative using this notation? Now let's compare 1 to 2. On 2, it asks you to find a slope of a tangent line at a point. And since we know what the derivative represents, the tangent line at any point on a graph, we can use the same limit process to answer question 2. So on question 2, I'm going to start with that same notation. I'm going to say f prime of x equals the limit as h approaches 0 of the function evaluated at x plus h minus the function itself. And then technically, it's all over x plus h minus x. But since those two x's cancel, it's all just over h. So this was much more of a problem than it should have been. When you learned rationals last year, you learned that you cannot add or subtract two rational expressions without finding a common denominator. So on the right, you need to multiply by x plus h plus 3. And on the left, you need to multiply by x plus 3 over x plus 3. So this next line is going to become the limit as h approaches 0 of x plus 3, and then on this side, minus x plus h plus 3. And that is all over the common denominator of x plus 3 times x plus h plus 3. And then since you're dividing by h, that's like multiplying by 1 over h. So when I simplify, I'll say, well, I have the limit as h approaches 0 of x minus x cancels, 3 minus 3 cancels. I have a negative h in the numerator and a positive h in the denominator. Now we can simplify those h's and we're left with the limit as h approaches 0 of negative 1 over x plus 3 times x plus h plus 3. Now when I evaluate my limit, I'm left with 1 over x plus 3 times x plus 3, which is really negative 1 over x plus 3 squared. So now I've found the derivative at any point on this graph, or I found the tangent line equation for any point on this graph. So now I'm going to take that step that they asked me to do in the instructions, and I am going to just use the screen. And I'm going to find the slope at a point. So I know a slope at a point is notated by f prime of x. And since the point is negative 4, negative 1, I'm evaluating for negative 4. So I get negative 1 over negative 4 plus 3 squared, which is really negative 1 over negative 1 squared, or negative 1 over 1. So the answer to the problem is f prime of negative 4 equals negative 1. So this question probably would be worth about 4 points. This one would be worth about 5 points. And then question 3 is building up another level, so that's worth about 6 points. So on this question, we're going to start, and it says, find an equation of a tangent line to the graph of f of x equals x squared minus 5x at the point 6, 6. So if I want to find an equation for a tangent line, I need to know a point, which I know, and the slope at that point, which I don't know. And I know to find a slope at a point, I need to find a derivative. So I'm going to say f prime of x equals f of x plus h minus f of x all over x plus h minus x. Oh, I almost forgot the limit. That would have killed me. Notice everything's clear and concise. Fractions have separate lines. I can read everything. So x plus h squared is x squared plus 2xh plus, plus h squared minus 5x minus 5h minus x squared plus 5x all over h. So now I'm going to simplify the numerator, and I get the limit as h approaches 0 of x squared minus x squared, and then I have 2xh plus h squared, the 5x's cancel, minus 5h. Now on another line, I get the limit as h approaches 0 of 2x plus h minus 5. Now I'm going to evaluate my limit. Let's say, what is the limit as h approaches 0? Well, it is 2x minus 5. So far, that's all the points for finding the derivative using the definition of a limit. Now it asked me to find an equation for a tangent line. So I need to know the slope at a point. So I'm going to do like I did in the last problem, and I'm going to say, okay, f prime of 6 is 2 times 6 minus 5, which is 7. And now to write the equation of a tangent line, it's y minus y1 equals your slope times x minus x1, y, right? So you can leave it like this, or sometimes in the video, we rewrote it like that. Neither is better nor worse. Pros and cons to both. The only benefit I see to that second notation is when you're asked to do problems like 7. So we had some very weird answers to that 7. Makes me think some of you may skip questions in your homework and then just not ask questions later. So we're going to do it down here. So when we look at question 7 here, for part A, it says find an equation for a tangent line when x equals 8. So that one, more of you answered, and you said, okay, my point is 8, 5, and my slope at this point is 11. So y minus y1 equals your slope, times x minus x1. So I'd say the majority of you did that correctly. Some of your notation was really weird, but at least you got the gist there. Most of you skipped part B. So part B, it asks you to use a tangent line approximation to find h of 7.8. Now, what is a tangent line approximation? A tangent line approximation uses a tangent line to approximate a value of a point that's near the point you wrote the tangent line for. So because 7.8 is close to 8, and because a tangent line is close to the curve, you can come up with a good approximation for h of 7.8 by plugging in 7.8 for x. So when I plug that in, 7.8 minus 8 is negative 0.2, or negative 2/10, right? So this is like saying 11 times negative 2/10, or negative 1/5. So negative 11/5. So I can move that 5 over, and I could say, well, then it means y equals negative 11/5 plus 5. And I know 5 is really 25/5. So negative 11, 25, 14. So 14/5, or 2 4/5. So that's a tangent line approximation. More often than not, though, doing that same process, I'm going to have to fix some of that I just lost. You'll see it written like this. And the reason you're going to see it written like this is because you know it's not just any old y, it's y at a specific point. And 4/5 is 8/10, so you could also write it like that. That's the general process. You guys were mostly fine with your graphs, except for the fact that you tried making one graph with all these qualities rather than 4 different graphs. You were decent with knowing where they were continuous or not continuous, except that some of you just listed the points rather than saying not continuous at blah, 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 blah. Or some of you would say, which is probably better notation, it is continuous everywhere except. And then most of you were pretty decent about estimating a derivative using the average rate of change. So using these values and your equation for average rate of change to estimate the instantaneous rate of change at that point. Some of you need to look back at ways to denote the derivative of a function. And then 5, a compare and contrast. So normally we do a little more of these in Honors Algebra 2 than I did, and I usually did a lot of them when I taught pre-calc, but compare and contrast. You're headed to college next year. No matter what you major in, you probably will be asked to compare and contrast at some point. If you put bullet points, you're probably going to get 0 points. It's kind of like when a professor or a teacher asks you to explain. So shouldn't be using bullet points. You could use a supplemental graph to help assist you. So you could sketch a graph off to the side and refer to it within your compare and contrast. But a compare and contrast is sentences. Most of you are in AP Lit, you can write a sentence. So not just what each is separately, but how are they similar? How are they different? And I'm not going to give you an answer to that one because I want you to figure that one out for yourself, even if you need to talk to a buddy. But we've been working on average rate of change and instantaneous rate of change for a while now, and you should be able to compare and contrast those. So I hope some of these tips improve your scores before the quiz next week. But honestly, we're not going to keep doing no for feedback unless you guys take it more seriously than you did this last time.